Okay, so math with McComish. This time we're going over multiplying a polynomial by a monomial symbolically, so not with a model. So the steps are we're going to use the distributive property, just like you would have with just a constant. Multiply every term in the brackets by what's on the outside. That's distributive property. A variable is multiplied by a variable, and the constants are multiplied by constants, or the coefficients. So we're going to have to review the exponent laws for this. So let's do that quickly right now. So exponent laws, remember, if the bases are the same, so if it's an x times an x squared times x to the fifth, then you add the exponents. So this ends up being x to the exponent 7. Okay, if you did 4a exponent 5 times 6a exponent 7, you do 4 times 6, so that's 24. A to the exponent 5 times a to the exponent 7 is a to the exponent 12. So we're going to use that a lot when we do this. So let's go over some examples here. 3x times x, so it's like there's a 1 here. So that would be 3x. Now, there's also like a 1 on for exponents for each of those. So x times an x would be x squared. Okay, so then I would do 3x times negative 5, so minus 15x. Okay, this one here, negative 8r times negative r would be a positive 8r squared. And negative 8r times negative 2 is positive 16r. And finally, this would be 8x squared minus 4x. So let's get to some trickier examples here. So in this case, remember, I'm going to take this 3 and times it by each one of the numbers. I'm going to take my x squared and times it by each one of the variables. Okay, so what this ends up giving me is 15 times by each of those. 15x, and since this is a 2, this is a 5, I add the exponents. So 15x to the exponent 7 plus 21x to the exponent 4 minus 6x to the exponent 3, because that one has an exponent of 1. So 2 plus 1 is 3, plus 3x squared. Okay, let's do this one. So 3y to the exponent 5 times negative 2y is negative 6y to the exponent 6 plus 12y to the exponent 8 minus 15y to the exponent 5. So this would give me negative 8y to the exponent 4 plus 16y to the exponent 10 plus 20y to the exponent 3. You could also be given a question like this. It could say, if x equaled 3, what would this expression equal? So the easiest way is to actually do the simplifying or the multiplication first. Then you replace 3 with every x. So this would give me 8x minus 10x to the exponent 5. So put 3 in for every x. So 8 times 3 minus 10 times 3 to the exponent 5. Okay? Make sure you do order of operations when you get to this. So you need to do 3 exponent 5 first. Then you can do 8 times 3 minus 10 times whatever that is. So you can use your calculator for questions like that. Another one like that. So let's first do the multiplication, and then you can simplify it. So this would give you 30g to the exponent 4 minus 20g to the exponent 5 plus 60g to the exponent 3. So to solve for this, if g equaled 2.4, I would put in my calculator to the exponent 4. So do your exponents first. Don't multiply 30 times 2.4 first. you have to do the exponent first on all of these. Minus 20 times 2.4 to the exponent of 5 plus 60 times 2.4 to the exponent of 3. So that's what you would put in your calculator. This one's a little bit tricky because there's two variables here, but only one out here. But it doesn't change things really. We still multiply constants, so this would be 12. And r cubed times ar is just ar to the exponent of 4. This would be minus 6r to the 12 plus 3r to the 5th minus 3a squared r to the 7th. So that's multiplication of monomials by polynomials.